Our next section is going to talk about altitudes, medians, and the two different bisectors of triangles. So we're going to start with altitudes first. An altitude of a triangle is a perpendicular segment from a vertex to the line containing the opposite side. Okay, so if we draw an altitude of this triangle, first thing we want to make sure we know is it's perpendicular, so that means it's going to have a 90-degree angle. And in this first example, if we draw an altitude of this triangle, it's going to go from the vertex and it's going to go straight down, so it's perpendicular to the opposite side. So this is our 90-degree angle, and this line right here, I'm going to call it A, is our altitude. So if we look at this example over here, if we were to draw the altitude of this triangle, we would start at our vertex up here. If we go straight down perpendicular to the opposite side, we actually need to extend this side out a little bit, and this is our altitude. So it's the height of this triangle. This is our altitude here, A. And if we had a right triangle, one sec. Let's try that again. If we have a right triangle where we already have a 90-degree angle, and if we were starting at this vertex trying to draw an altitude, our altitude would be this side right here, because if we go straight down and perpendicular to the opposite side, that is the side of our triangle. So the altitude could look like these three different lines depending on what your triangle looks like. So if we look at our next example, it says draw three altitudes for triangle ABC. So these are our points, A, B, and C. Okay, so our altitude could be at the top vertex, and if we go straight down from that vertex, we need to extend this side out a little bit. That's our 90-degree angle. That is one altitude we could draw. If we were to start from vertex B and go straight to the other side at a 90-degree angle, this is another altitude. Or if we were to start at C and we were to go straight to the other side, we would need to extend out this side of our triangle, go straight down, so it's 90 degrees. That is our third altitude. Okay, and it overlapped a little bit with this next example, but we can still read it. It says, solve for x if AC is an altitude in the triangle FAN. So let's label our parts. We have AC as our altitude, FAN is our triangle, and it tells us that this angle right here is 3x minus 30. Okay, so we want to solve x if AC is an altitude. So if AC is an altitude, that tells us right away that this angle here is 90 degrees. So we can set that 3x minus 30 equal to 90. Add 30 both sides. Get 3x equals 120. Divide by 3, and x equals 40. Okay, so those are altitudes. Altitudes are going from one vertex and they are going straight to the other side, perpendicular to the other line of the triangle. A median of a triangle is a segment from a vertex to the midpoint of the opposite side. So we're still starting at the vertex, but instead of going straight down, we are going to go to the midpoint of the opposite side. So the first thing we want to do is find the midpoint of our opposite line, and then we connect our vertex to the midpoint. So that's going to tell me that this side right here is going to be the same as this side right here, because that's my definition of a midpoint. midpoint is in the middle, so those two are going to be the same. So now that we know what a median is, this example is asking us to draw 3 different medians for the triangle ABC. So these are our points A, B, and C. For my first median, I'm going to start at point A, and I want to go to the midpoint of my opposite side, which would be right about here. I'm going to connect those 2 lines. For my second median, I'm going to start at point B. I want to go to the midpoint of this side, which is about right there. And then for my third median, I'll start at vertex C, and I want to go to the midpoint of the opposite side, which is right about there. Okay, and so those are all of our medians for our triangle ABC. Our next example says solve for x if AM is the median in triangle ABC. So this is our given information here. If this is A, B, and C, AM is our median, and this side is 2x plus 3, and this side is x plus 11. Okay, so if we know AM is our median, that means M is at the midpoint of this side, so that means our 2 sides must be equal. So we can set up our equation 2x plus 3 equals x plus 11. Solve that equation, move the x to the other side, and move the 3 to the other side. I get x equals 8. Okay, so those are the altitude and medians of a triangle. Now we're going to talk about perpendicular bisectors. For this example, I'm actually going to redraw this line, so I just want you to ignore this line, and we're going to redraw it over here. So if we have a segment AB, and this theorem is saying that if a point lies on the perpendicular bisector of a segment, so if we have a perpendicular bisector, the definition of that is that it is 90 degrees and it divides our segment into 2 equal parts. Bisector means it divides into 2 equal parts. So if we have a point that lies on that perpendicular bisector, like up here, it is always going to be equal distant from the endpoints of our segment. So if we were to go from point A up to our point, let's call it point M, or from point B up to point M, those distances would be the same. Right here would be equal to here. So then if we have a point equidistant from the endpoints of a segment, so in this case, theorem 5.1, if it is equidistant from the segment, then the point must be on the perpendicular bisector. So if we have a point up here, again, and we know that it is this distance and this distance are the same, then we know it's on the perpendicular bisector. So it's just the opposite of the first theorem. First theorem is saying first we know it's a perpendicular bisector, then we know it's the same distance away. The second one's saying if it's the same distance away, then we know it's on a perpendicular bisector. So it works both ways. So let's look at an example below. Okay, so we got to draw our picture. And our picture looks like this. We have segment CD and line SR. CD. Okay, it says line 1 is the perpendicular bisector of CD. So this is line 1. So if it's the perpendicular bisector of CD, that tells me right away that this part is going to be the same as this part. I'm going to name this point in the middle M. And if it's perpendicular, I know this is 90 degrees. So if RC, right here, this distance, is 6, and SD is 5, and CM equals 4, it wants us to find the missing pieces. So we need to find RD, SC, MD. I already know that one. That one is going to be the same as this one, 4, and CD. That whole segment I know is 4 plus 4, which is going to be 8. Now if I look at my point up here, I know that it is this line 1, is a perpendicular bisector of CD. So if it's a perpendicular bisector, that means any points on that perpendicular bisector are going to be the same distance from either endpoint. So if it's 6 to this endpoint, then I know it's going to be the same distance to this endpoint. This one is also going to be 6. So that is RD. Then I know if this point here is on my perpendicular bisector, I know SD is 5, the distance from that point on the perpendicular bisector to the endpoint of my segment. It's going to be the same distance to the other endpoint of my segment. So that is going to be 5.